Hello, everyone. My name is Ryan Pittman,
I'm Angel Bhattacharya,
And I'm Michael Gabriel.
and
and
we
we
are
are
Team RAM.
Team RAM.
Our Capstone project is a case study of ARK Invest ETFs. Who is Kathy Woods, and what is ARK? Well, for starters, ARK is an acronym that stands for Active Research Knowledge. It is an investment firm founded by Kathy Woods, the current Chief Executive Officer and Chief Information Officer of the company. The purpose of this project is to evaluate the performance of ARK ETFs, specifically ARK-K, and to make recommendations to Kathy Woods that would boost her returns while simultaneously taking her stock preferences into account.
The work of this project was done entirely using Python in Lab Studios. The use of Python allowed us to compile lists in ways that were easy to understand and allowed us to work easier with the data provided. We initially started by compiling a master list of ETFs given the top 5 ARK investments. After creating this list, we removed inconsistencies and duplicates, leaving us with a more refined master list. We then used a list of tickers as X and the weight of each they have on the ETFs as Y, and compiled a bar graph. We then sorted the tickers to organize the graph in ascending order. The graph depicted shows the top 10 ticker values. This analysis shows us which stocks would have been the best for Kathy Woods to invest in. Pandas is an open source Python package that is most widely used for data science, data analytics, and to support machine learning tasks. It is built on top of another package named NumPy, which provides support for multi-dimensional arrays. We use Pandas to work with data frames by initially trimming the data, converting the data to float. Later, we removed the last 2 non-essential columns from the work and set the tickers to be the index. This was all done in order to conclude which tickers we would recommend to Kathy. Pandas allowed us to read the data into easily understandable data frames from which the work could be done. Web scraping, or web parsing, is a process of collecting and parsing through raw data, oftentimes from the web, in order to create a more refined and useful list. While web parsing, we were able to clean the data, we were able to refine our list of tickers, get the holdings of each, and then create a data frame with the newly compiled information. The aim of this part was to break down which stock types Kathy prefers to later make our recommendation on what to invest in. We ran similar tests to find what investments Kathy held and what percentage of her portfolio is being supported by her holdings in each industry. In this graph, we can see that the tickers in the tech industry have the highest chance of making the biggest return. Here on the right, we can see the graph of the industry that Kathy invests in and does not match up with the most profitable choices she could be making.
Our first step was data preprocessing. There are 2 features shown before you, functions shown before you. The cleanup function allows us to remove postfixes, append necessary placeholders, and convert each string value to a float for all records in our FinViz database. The convert string to float function handles columns that either have missing data or 2 values that need to be either averaged or difference. It calls the cleanup function to convert those data values to floats. Our second step was to perform linear regression on the Pandas data frame in order to choose the most significant predictor variables in stock market forecasting. To do so, we utilize the OLS operator in Python to perform t-tests and f-tests based on our linear regression models. We conducted our t-test at a 1% level of significance. The features we found most significant are shown below. We ran the summary statistics for the model with all features and the model with only our selected features. As depicted in the charts, the new model has a lower R-squared and adjusted R-squared values, most likely due to an increase in bias and decrease in variance. However, this new model does abide by the law of parsimony and is more significant than the prior model at stock market forecasting based on the results of the f-test. Next, we wanted to see which type of stocks Kathy Woods prefers. After performing unsupervised learning techniques like K-means clustering, we learned that she prefers stocks from cluster 3, highly volatile stocks with sales growth but negative earnings, aka the kind of stocks that are performing terribly in today's economy. Here are the distributions of stocks based on each cluster among all of her ETFs. Our next step was to use a priori algorithms to identify and suggest stocks that competing ETFs are buying. Such high innovation ETFs include QQQ, ROBO, and QQQJ. We originally tuned the algorithm with a support level of 0.1, which provided 312 recommendations to Kathy Woods. Changing the support level to 0.3 narrowed these recommendations down to the top 23. We labeled this list CompRec, and the tickers it holds are listed below. They include big tech companies, e-commerce companies, and innovative startups like Intuitive Surgical and Lucid. Unfortunately, a priori only makes recommendations based on what ARK and its competitors have in common, but not necessarily the features that Kathy Woods idealizes. Therefore, we concluded that it might be a good idea to perform K-means clustering on the CompRec list and suggest only the stocks from CompRec that fall under the cluster 3 category.
After doing K-means and a priori unsupervised learning, we performed KNN supervised learning. We split the data into a training set and a testing set. Then we created an instance of the K-neighbors classifier and fit the data. We experimented with the number of neighbors. We tested 5, 10, and 100 neighbors. Looking at the accuracy scores for each test, the K-neighbors classifier with 10 neighbors performed the best. We fit the data into a KNN classifier with 10 neighbors and ran it 15 times. Then we predicted the probability for each of the tickers in FinViz SGD and filtered out the tickers with a probability higher than 70%. We removed the tickers that Kathy Woods already had in her portfolio and were left with these remaining tickers as a suggestion from KNN. This list that you see on the screen is going to be significant later when we compare it with all of the other lists of recommendations that we created. In order to find the best model, we ran K-neighbors classifier, Gaussian NB, linear discriminant analysis, logistic regression, SVC for the following kernels, linear, poly, RBF, and sigmoid, and the decision tree classifier. With the test accuracy of 95%, we concluded that SVC with the kernel RBC is the best model for our data. Even though the decision tree classifier resulted in the highest training score, we ignored that because we knew that the testing score is a more accurate predictor of model success, whereas the training score is a reflection of how well the model can memorize the answers. After fitting the data into a SVC model for the kernel RBF, we ran it 15 times and compiled a list of tickers to recommend, which you can see on the screen. At this point, we have several lists of recommendations from multiple models. In order to pick the best list, we plotted the returns of each of the lists. First, we will focus on the jumble of lines down below, and we'll go from worst to best. At the very bottom, we have KNN, then SVC RBF, which we had originally predicted would do the best, however, it didn't. And then we have SVC linear. Slightly above that, we have ARK. This dark blue line represents how ARK is doing on its own without any of our recommendations. Then slightly above that, we have new ARK, which represents the performance of the entire dataset and not just a subset of features being fitted into a KNN classifier. Then skyrocketing all of these, we have the orange line, which is the comprec list of recommendations that we got from our a priori model. We then realized that this model had not been optimized yet because although it chose recommendations based on the stocks Cathie Woods already had, it doesn't necessarily take into consideration the criteria that Cathie Woods values, such as technology and innovation. So we decided to add another line of a priori recommendations, except we filtered them so that they only included cluster 3 stocks because we knew that Cathie Woods values cluster 3 stocks. And this outperformed all of the previous recommendations, as you can see from the highest line called a priori cluster 3 only. Given this data from our graph, we decided to compile a final list of recommendations, which consists of these 4 stocks: Lucid, DocuSign, Datadog, and Match. And yes, so these are the 4 recommendations that we have for Cathie Woods. Thank you for watching our video. And if you have any questions, please let us know.